No general procedure for bug checks will do. Now I won't just assert that, I'll prove it to you. I will prove that although you might work till you drop, you cannot tell if computation will stop. For imagine we have a procedure called P that for specified input permits you to see whether specified source code, with all of its faults, defines a routine that eventually halts. You feed in your program with suitable data, and P gets to work, and a little while later, in finite compute time, correctly infers whether infinite looping behavior occurs. If there will be no looping, then P prints out good. That means work on this input will halt as it should. But if it detects an unstoppable loop, then P reports bad, which means you're in the soup. Well, the truth is that P cannot possibly be, because if you wrote it and gave it to me, I could use it to set up a logical bind that would shatter your reason and scramble your mind. Here's the trick that I'll use, and it's simple to do. I'll define a procedure which I will call Q, that will use P's predictions of halting success to stir up a terrible logical mess. For a specified program, say A once applies, the first step of this program, called Q I devise, is to find out from P what's the right thing to say of the looping behavior of A run on A. If P's answer is bad, Q will suddenly stop, but otherwise Q will go back to the top and start off again, looping endlessly back till the universe dies and turns frozen and black. And this program called Q wouldn't stay on the shelf. I would ask it to forecast its run on itself. When it reads its own source code, just what will it do? What's the looping behavior of Q run on Q? If P warns of infinite loops, Q will quit, yet P is supposed to speak truly of it. And if Q's going to quit, then P should say good, which makes Q start to loop. P denied that it would. No matter how P might perform, Q will scoop it. Q uses P's output to make P look stupid. Whatever P says, it cannot predict Q. P is right when it's wrong, and it's false when it's true. I've created a paradox, neat as can be, and simply by using your putative P. When you posited P, you stepped into a snare. Your assumption has led you right into my lair. So where can this argument possibly go? I don't have to tell you, I'm sure you must know. A reductio there cannot possibly be a procedure that acts like the mythical P. You can never find general mechanical means for predicting the acts of computing machines. It's something that cannot be done, so we users must find our own bugs. Our computers are losers.